Hi, welcome back to my YouTube channel. My name is Anmok Abdulwahab and I'm a college math instructor. In today's video, we're going to look at how to use Pascal's triangle in binomial expansion. So let's just get started. Okay, now what is binomial expansion? So let's first of all understand what this means, right? It's expansion of the form any x plus y raised to power n, right? It's expansion of this form where n is positive integer, right? That's what a binomial expansion is, okay? Now, how do we expand this? Now, the classical way of expanding this, so let's first of all do that. The classical way of expanding this is this. So the first thing is that in each of this expansion, you're going to have a coefficient and then if followed by a variable for each term of this expansion. And this is what it is first of all, we use this n combination 0. Then we take the first term, we take it to the highest power, and then the second term to the lowest power. All right, the highest power is n, the lowest power is 0. Then the next term, we move one step further. The 0 becomes 1, so we have n combination 1. Then we reduce the power of the highest of this one by 1, and then we increase the power of the second term by 1. And we continue to do this until we reach the last term. So the next one will be n combination 2, x raised to power n minus 2, y raised to power 2. The next one, n combination 3, x raised to power n minus 3, y raised to power 3. Now this will continue. It's going to stop somewhere, right? Well, how will it stop? It will stop when this 0 gets up to n, right? So let's write the next one, the second to the last one. So let's say what we have here gets to n minus 1. So we have n combination n minus 1. Then at that point, what will happen is what? X will now be to the power of 1. So it would have reduced to the power of 1. And y would have increased to the power of what? N minus 1. Therefore, the last term will be n combination n. The first term will be x raised to power 0. And the second term would be to the power of n. Now, this is briefly binomial expansion. Then we can apply in this to sample problems like this to kind of do all of these things. Now, the third is the classical binomial expansion. Okay. Now, what happens is you can actually also reverse the powers. Or what I mean is we can reverse whether x takes maximum power here and y takes minimum power. We can reverse it in such a way where we start with n combination 0, x takes the minimum power, y takes the maximum power, and so on and so forth. You can see, and it just so happens that what n combination 0 is just the same thing as what n combination n. There are so many properties for this type of expansion, and we're going to explain those before we get right into these problems. Okay, now the first thing that I would mention is the Pascal's triangle. So what's the role of Pascal's triangle here? Okay. Now, what does this do? Now, in this binomial expansion, as you can see, each term has coefficients, right? N combination 0, n combination 1, n combination 2, up to n combination n. Now, instead of using combination to find these coefficients, we can use Pascal's triangle. But first of all, let's define what a combination is. So if I have n combination r, of course, r is between 0, 1, 2, up to n, as you can see from this expansion. This is given as n factorial over n minus r factorial times r factorial. Or maybe I should write it in a much bolder form. N factorial over n minus r factorial times r factorial. Of course, r is moving between this up to n, okay? Now, this is how we find combination. Now, it turns out that this coefficient, so it turns out that this coefficient can be written using Pascal's triangle. Now, let's build the triangle together. So the first term in this triangle is 1. The next term, we start with 1, 1. Remember that, notice that we put in this one in the middle. Now, always we are going to start with 1, okay, and end with 1, right? Now, and what do we do next is, the next term here would be the addition of these two together. So we add these two terms to give us what is the coefficient in between those two numbers. So 1 plus 1 is 2, and then we end with 1 again. In the next level, we start with 1. We add this together to give us 3. We add this together to give us 3, and then we end with 1. So we continue in this fashion, right? And it's kind of nice, kind of cute. So we continue in this fashion. So 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and then we end with 1. So we continue this way. So you can build this to any length. So it's kind of a pyramid, right? The next one is 6, 15. So we'll stop here. 6, 1. And we'll be referring to this Pascal's triangle later on. Now, what do we use this triangle to do? This tells us the coefficients that we need for the expansion, for the binomial expansion. Now, the first level is for expanding, is the coefficients for expanding x plus y raised to power 0 when n is 0, right? This is the coefficient we use for when n is 1. So n is 0, here n is 1. This is the coefficient we use for what? When n is what? 2, right? This is the coefficient we use for when n is what? 3, and so on and so forth, right? So that means this is for 4, for 5. So this is for expanding n equal to 6, basically. Now, how do we use this in the expansion as we've just stated? Now let's take an example to take a look at how we use this. Let's say I want to expand x plus y raised to power 3. Okay. Now what this thing says is, remember, all we are saying is these coefficients will be replaced by these numbers. Now, power of 3, which level are we going to use? We are going to use this level. This is the coefficients we'll be using for the expansion of x plus y raised to power 3. Now, what it means is the first coefficient of this expansion will be this 1, okay? I will have 1, then I will take x, multiply by x raised to power the highest power, then y raised to power the lowest power. Can you see what is happening? Plus, the next term would have the coefficient 3, okay? Then reduce the power of x by 1, increase the power of y by 1, plus the next term would have the coefficient of 3 again, reduce the power of x by 1, increase the power of y by 1, and then you can see x was 2, power of x was 2 here, now it's now 1, power of y was 1, now it's now 2. Then finally, the last term would have 1, reduce the power of x by 1, increase the power of y by 1. Now all we need to do is just to evaluate each of these terms. So 1 times x squared. So what I generally advise my students to do is to put brackets around each term, right? So that you know how they are multiplying, right? So it's not so necessary for this particular problem. You'll see in other problems later on that it becomes necessary to do this, okay? Now, what does this mean? 1 times x raised to power 3 times y raised to power 0. This is just basically x raised to power 3. Y raised to power 0 is 1, okay? So that means the first term is x raised to power 3. What about the second one? We have basically 3x squared y. The third one, we have 3xy squared. And the fourth one, we have y cubed, okay? So this is the expansion of x plus y raised to power 3. Now, when we get to higher powers and when the terms here change, it becomes a little bit tricky to do this expansion. All right, so we understand what Pascal's triangle is. Let's use it to solve the problems that we have in the question. So the first one is question 1, okay? It says we should expand 1 minus 5x raised to power 5, okay? Now, what does that mean? We're going to use this level, right? This is the 5th. So this is 0th level, 1st, 2nd, 3rd, 4th, 5th. So we're going to use these coefficients to expand this particular problem, okay? So keep in mind you have 1, 5, 10, 10, 5, 1, okay? So let's just quickly write the coefficients, 1, 5, 10, 10, 5, 1, okay? Now, what happens is, again, we start with the first coefficient, 1, multiply by the first term, which is 1 here, don't forget, this is the first term, raised to power what? Highest power. And then the second term, which is minus 5x, don't forget, it goes with the sign in front of it, minus 5x raised to power 0. Plus, you can see now I'm putting bracket around it to make it easy to see what is happening. Then the next one is, the next coefficient is 5, right? The next one is 5. Multiply by the first term, reduce the power by 1, increase the power of the second one by 1. This is what you keep doing. Next term, next coefficient is 10. Reduce the power of 1 by 1, increase the power of minus 5x by 1. Then we continue. Next one is 10 again. Reduce the power of 1 by 1, increase the power of this by 1. Then the next one is 5. Reduce the power of this by 1, increase the power of this by 1, plus. Finally, we have 1, the last coefficient. Reduce the power of this by 1, increase the power of this by 1. And now what you have, once you get here, most students don't know how to simplify each of the terms. So since you're not most students, so we're going to break it down, how to do it. Now take it term by term. So I have 1 times 1 raised to the power 5 times minus 5x raised to the power 0. I know this is 1, this is also 1, and this is also 1. So my first term here is 1. I'll move on. Now the next one is 5 times 1 raised to the power 4 times minus 5x raised to the power 1. So I just have 5 times 1 raised to the power 4 is 1 times minus 5x. And this will give me minus 25x. So this is how I know the next term here is going to be minus 25x. We can see how I'm operating this. Now, what is the next one? The next one, so let's delete this to make space. So the next term that we need to simplify is basically 10 times 1 raised to the power 3 times minus 5x squared. Now this gives 10 times 1 raised to the power 3 is 1. The minus 5x all square. Notice that what? This square is affecting both minus 5 and x. So this is going to be minus 5 square times x square. So what is minus 5 square? That is 25. So 10 times 25 times x squared. So that is 250x squared. So the next one is 250x squared. Okay, what about the next one? The next one is 10 times 1 square times minus 5x cubed. Now, why we are putting bracket around the whole term is because we want to signify that this power of 3 affects both minus 5 and x. So don't make that mistake to just think that what the power is affecting only x is also affecting the minus 5. So we have 10 minus 5 raised to the power 3, x raised to the power 3. This is minus 10. So this is 10 times, this is minus 5, minus 5 raised to the power 3 is basically 25 times 5, that is 125, is minus 125. So we have, so basically this minus supposed to come in front here, right? X cubed. So this will give us minus 1,250. So minus 1,250 x cubed. Okay. Now we move to the next one. We have 5 times 1 raised to the power 1 times minus 5x raised to the power 4. So what will this give us? Again, we need to do 5. So we need to check. This is 5 times minus 5 raised to the power 4 is going to be 625. Then x raised to the power 4. So this will give us times, this will give us 3,125, 3,125 x raised to the power 4. And finally, we have, so finally, let's simplify the last one, which is 1 times 1 times minus 5x raised to the power 5. So this is just 1 times 1 times minus 5 raised to the power 5. Then x raised to the power 5. So 5 raised to the power 5 is what? Yes, it's also 3,125. Now, remember, it's minus 5 raised to the power 5, so that will be minus 3,125 x raised to the power 5. So this will be the expansion of for this particular problem. Okay. Now, one thing that you should note is the next question that you might have is what is the coefficient? So let's just do that. What is the coefficient of x cubed in the expansion? We're going to show this in future videos as well, in the expansion of 1 minus 5x raised to the power 5. And your answer here is just this number in front of x cubed. So the answer will be minus 1,250. Okay. What about the coefficient of what? X squared? That will be 250. Coefficient of x is minus 25. okay, and so on and so forth. All right, so that's the solution to the first problem. Let's look at the second one. Okay, the second one says 1 plus 3a raised to power 4. So question 2, so let me just make it thicker. We are doing 1 plus 3 over a all raised to power 4. We are doing this expansion. So don't forget, you need to know the coefficients for the power of 4, which is this one. The coefficient is what? 1, 4, 6, 4, 1. So that's what you're going to use for this expansion. Okay, so let's quickly do that. So which means the first coefficient times the first term raised to power the highest power, then second term raised to power the lowest power. Next one, we use the next coefficient, which is 4. Then the first term raised to power, reduce the power by 1. Second term, increase the power by 1. Then 6, reduce the power by 1, increase the power by 1. Then what is next? I think the next coefficient is 4. Reduce the power by 1, increase the power by 1. And finally, reduce the power. So the next space, reduce the power by 1, increase the power by 1. Okay, now the next thing is just to simplify now. Like we did previously. So 1 times 1 raised to power 4, 3 over a raised to power 0. This is just 1 times 1 raised to power 4 is just 1. 3 over a raised to power 0 is just 1 as well. So you just have 1 here. Then the next one, 4 times. So let's do it here. 4 times, let me create space. Okay. So we are doing 4 times 1 raised to power 3, 3 over a raised to power 1. This is quite easy. This is 4 times 1 raised to power 3 is 1 times 3 over a. So this is just going to give us 12 over a. Okay. Now the next one, 6 times 1 square, 3 over a square. So what would this give us? 6 times 1 square is 1. Now 3 over a square is what? Remember, it's just like 3 over a times 3 over a. That is 3 over a all square. Okay, so this will give us 6 times what? 9 over a square. And 6 times 9 is, I think, 54. So 54 over a square. So we have 54 over a square. What's the next one? We have 4 times 1 raised to power 1, 3 over a raised to power 3. And this is 4 times 1. 3 raised to power 3 over a raised to power 3. So this is 27 times 4. Don't forget that 3 raised to power 3 is 27. So 27 times 4 is 108 all over a cube. So this would be 108 over a cube. And finally, we have 1 times 1 raised to power 0, 3 over a raised to power 4. So what does this give us? 1 times 1 raised to power 0 is 1 times 3 raised to power 4 over a raised to power 4. So 3 raised to power 4 is 81. So we have 81 over a raised to power 4. So this is the expansion for the second problem. You can see it's quite easy using Pascal's triangle. All you need to know is to be able to deduce these levels, right? The coefficient for each level of for each corresponding to the expansion for that level. Okay. Now the last one, which is 1 plus x squared raised to power 5. So the next one is 1 plus question 3, 1 plus x squared raised to power 5. Now we are using the power of 5, and what is the coefficient for the power of 5? We have 1, 5, 10, 10, 5, 1. 1, 5, 10, 10, 5, 1. These are the coefficients for this expansion. So we start with the first coefficient. The first term is also 1 again, raised to the highest power. The second term to the lowest power. So I will just write it out. Reduce the power of this by 1, increase the power of this by 1. Increase the power of this by 1. The next one, 10 again. Increase the power of this by 1. The next one, increase the power of x squared by 1. And finally, the last one, this becomes 0. So if you do it correctly, the first term will start from the highest power up to the lowest power, and the second term will start from the lowest power up to the highest power. That is how it works. If you do not use the right level of coefficients, this thing will not match exactly this way. So you observe that what for expansion of what power of 5, you have 6 terms. You'll see you have 6 coefficients, right? If it is 7 here, you would have 8 coefficients. That's how it works. So make sure you use the right level for your expansion. Now let's quickly finish this problem. So the first one would be evaluation of 1 times 1 raised to the power 5 x squared raised to the power 0 is just 1. So you can figure this thing out now. 5 times 1 raised to the power 4, which is 5 times x squared, that will be 5x squared. So the next one we have 10 times 1 raised to the power 3, which is 1. X squared is going to be x raised to the power 4. So the next one will be 10x raised to the power 4. What about the next one? It will be 10x raised to the power 6. That means 2 times 3 is 6. So don't forget your rule of what? Indices. This will be x raised to the power 2 times 3, which is x raised to the power 6. Okay. What about this one? This will be 5x raised to the power 8 plus this is 1, this is 1, this is x raised to the power 10 plus the coefficient is 1, so we just have x raised to the power 10. And this is the expansion of the third one using Pascal's triangle. And this brings us to the end of this video. If you haven't subscribed to the channel, make sure you do subscribe to the channel and like the video, share this video on your various social media channels so that other students like you can find this channel and benefit from it. And also click the bell button so that anytime I upload a new video, you'll be the first to know about it. And that brings us to the end of the video. I will see you in the next one, which will be still on binomial expansion, but using binomial theorem that I stated earlier on here. Okay, so we'll be using this theorem to solve the same problem, similar problem that we've just solved. So our focus will be in using this theorem, right? Okay, so see you guys in the next video.